What is up, everybody, and welcome back to the Cloud Engineering Bootcamp, where we're learning skills that will allow us to build AI-ready infrastructure. And in this video, we're going to talk about what cloud engineering is. Let's get started. So, cloud engineering is the practice of designing, building, and managing cloud computing infrastructure. And in our case, the context is going to be AWS. So basically, cloud engineers spend their time designing, building, and managing infrastructure. And the whole goal behind their role is that they build infrastructure on AWS or any other cloud platform for that matter, that's scalable, that is secure, and that is efficient and optimal over time. Right. So in these categories, designing, building, and managing, there are certain things that need to be done in order to then be able to deliver that infrastructure. So let's look at each of them. So in the design part of the role, they do a couple of things. One is they gather requirements. That's the first thing. So the whole point of gathering requirements is to understand the business needs, both from a technical perspective as well as from an operational perspective. And the goal there is to meet with as many stakeholders as possible, gathering these requirements in order to then identify the timelines, the budgets, the existing tooling, but obviously to gather the aim of the current project at hand, because that then informs how this whole process will be approached. Once they've gathered requirements, they then begin to analyze the workload itself, meaning that they are trying to determine what the workload will need in order to perform optimally. So they'll identify it from the perspective of networking, from the perspective of compute, from the perspective of storage, and what its data needs are going to be. And once that identification process has happened, the cloud engineers then take a step back, look at the information that's been gathered in terms of requirements, and look at the information they've analyzed in terms of the workload itself, and begin to make decisions, right, around the design patterns that will be used as well as the services that will be used. So these decisions really revolve around compute models. So they then look at, having looked at the workload, decide, are we going to go serverless with this? Is this going to be a containerized applications, or is it going to use traditional VMs? From a storage model perspective, they start to look at, are we using things, services like S3, EBS volumes, RDS databases? From a deployment perspective, they then look at, are we using a single region? Is it a multi-region? Is it a hybrid setup where we are creating a integration between the cloud platform and what's existing in the organization's data center? So those are the sort of things that they holistically look at a design phase. The whole output of the design phase is a clear documentation that specifies what needs to be done and how much of it needs to be done. It specifies the budgets, timelines, and as well as at the output at this point is that there is an architectural diagram that stipulates what needs to be done. And all of these documents will then inform the next step, which is to build. So let's get into the build phase. In the build phase, the cloud engineers then start to build the infrastructure, meaning that they use the knowledge from the design phase and start to write the code necessary to build that infrastructure. There's various tools that they use. It could be CloudFormation, it could be Pulumi, and it could be Terraform. Now, in our case, it'll be Terraform, meaning anytime we are coming across a situation where we have to create infrastructure, we will use Terraform to write the code for that infrastructure. And the reason for that is quite simple. Writing code to provision infrastructure allows us to write infrastructure, obviously, that's maintainable, that is consistent, and that's well documented. Part of writing that infrastructure is also integrating it with version control systems. And in our case, it'll be GitHub. And GitHub essentially will be the source control mechanism we use to ensure collaboration, etc., etc. But also within GitHub, what cloud engineers do, and what we will do in this case, is then to write or create what is known as CI/CD pipelines for deployment. In other words, we're gonna streamline, if you will, the whole process of building writing the code to build the infrastructure, the collaboration aspect and source control of the infrastructure, as well as the automated deployments of that infrastructure. So that's what's happening in the build phase. As we're building, however, the other thing that happens is that cloud engineers then need to integrate security and compliance into all of that, right? So as to ensure that the infrastructure is secure and compliant. So in the networking aspects of the workload, we'll look at things like firewalls and security groups. We'll look at how we're going to manage IAM policies, how we're going to manage encryption from a data perspective, from a traffic perspective, and how to then ensure security and compliance from a regulatory standards of the organization itself. Lastly, in the build phase, it's about deploying that infrastructure, meaning we provision the coded infrastructure that we were writing in Terraform, using the CI/CD pipeline process that we had set up to automate that whole process. And the key thing here is that post the deployment, there is monitoring of performance, and then we start to gather feedback from what we've deployed. And obviously, this is in reference to the workload itself, because once the infrastructure is in place, the workload itself can start making use of that workload. And that's where we start to get feedback in terms of what do we need to tweak within the infrastructure that's been built already. Post the deployment as well is we start looking at the third phase, which is the management aspect of the role of a cloud engineer. And in here, we're really focused on two things. Number one is it's monitoring and optimization. In terms of monitoring, we're trying to gain insights into the system's health and performance. Is it doing what it's supposed to, and is it doing it optimally? Meaning that we need to set up the logging and monitoring tools that are available. It could be CloudWatch, or it could be open source tools like Prometheus and Grafana. And we'll try to work with a varied options of tools when it comes to monitoring. But not only do we want to be able to monitor things as they happen, but we also want to be informed if things are not going as they should. So that's where alarms are going to come in. But also we want insights that are visually presented, and that's where we're going to bring in dashboards for our workloads and in the infrastructure. Then the last thing that cloud engineers do, which we obviously will do ourselves, is then to optimize scalability and cost. And basically what we're trying to do here is that we're trying to balance efficiency with cost effectiveness. So on the one hand, we're trying to have a situation where the infrastructure is allowing the workload to be performant and to ensure that it works at a high standard and with high quality, but at the same time trying to balance that with making sure that the costs incurred to do that are optimized. We're not wasting money. So we'll try and use caching solutions where possible. It might mean right-sizing instances where possible, and tagging in order to keep track of what's how workloads are consuming or adding or contributing to the cost rather, and how we then enforce budgets to ensure that we stay within the constraints that we're given in the gathering phase. All right. So this is the whole process of the cloud. I want to say this is the whole process, the cloud engineering process, that you are going to really see as we are going through the modules. It'll really be, we'll often come back here to remind ourselves, okay, have we gathered the requirements? Have we analyzed the workload? Based on what we've gathered, have we chosen or selected an architecture, and so on and so forth. I hope this has been helpful in answering the question of what is cloud engineering, and what cloud engineers essentially do at a high level. Hope you found value in this video, and I'll see you in the next one, because in the next one we'll start looking at the role of cloud computing in AI systems. Thank